And we're back. All right, 3 more area formulas today: triangle, trapezoid, and rhombus. So, the area of a triangle can be calculated if you know the base and the height of the triangle. And remember, in all of these formulas, when we say height, we mean the length of the segment from a vertex to the base that makes a right angle. So this is not the height of the triangle, this is not the height of the triangle, this is the height of the triangle. So I think a lot of you know this formula, but I'm going to challenge you to hit pause and see if you can figure out why the formula is what it is. So if you're interested in doing that, hit pause. All right, it turns out these formulas kind of all build off each other. If I take this triangle and put a copy of it upside down right next to it, just rotate it 180 degrees, it would look something like this. So this is the same triangle right next to the original one. So this base is now up at the top, and this height is here. And together, those two triangles form a parallelogram. We know it's a parallelogram because one of the tests for a parallelogram from back in chapter 6 is any quadrilateral with both pairs of opposite sides congruent, which is what we have here, must be a parallelogram. And we know from the previous video that a parallelogram is a rectangle in disguise. So if we just imagine moving this right triangle over here, we'd have a rectangle with base and height of h. So the area of this parallelogram we know is base times height. Area of any parallelogram, previous video, is base times height. But the question is, what's the area of just that black triangle? Well, that takes up exactly half as much space as the parallelogram does, so it's exactly half as much as base times height. There it is. Any triangle's area is 1/2 base times height because it's just half of a parallelogram with the same base and the same height. Remember, the height has to be perpendicular to the base. So you can add this to your flashcards or your list if you're keeping such notes. Next one, trapezoid. So same thing, if you want to challenge yourself, hit the pause button. Can you figure out how we could get the area of a trapezoid if we know the length of the two bases, which are the parallel sides, and if we know the height? So if I told you this was 10 and this was 4 and this was 3, can you figure out how we'd know what the area is? And here we go. Exact same reasoning as the triangle. I'm going to put a trapezoid congruent to the black one upside down right next to it. Just rotated 180 degrees. So there it is. So now this top base, base 2, is down here. And up here is what used to be the bottom of the black one, base 1. Sorry for the bad writing, I'm kind of writing at an angle to keep the paper oriented towards the camera. And the height would be here. But together they form a parallelogram. Both pairs of opposite sides are congruent. The bottom of this parallelogram has a length of base 1 plus base 2. Base 1 plus base 2. And the height of this parallelogram is this perpendicular segment length here. So the area of this whole parallelogram would be this entire base times the height of the parallelogram, which is that h. So the entire base times the height. But we only want not the whole parallelogram. The original question was, what's the area of that black trapezoid? Well, that clearly takes up only half as much space because it's one of the two trapezoids that makes the parallelogram. So we multiply by half, and that's the formula for the area of a trapezoid. Half of the height times the sum of the bases. When we do an example problem in the next video, I'll show you a nice little shortcut to this, but that's the formula. Last one. Area of a rhombus. This one's a little trickier to figure out. Now, a rhombus is a parallelogram. So we could do base times height if we knew this perpendicular height. But in most rhombus problems, you don't have that information. It's not easy to get. It's actually something we can calculate if we know how long the two diagonals are of the rhombus. So I'm going to refer to this red diagonal as diagonal number 2. The black one is diagonal number 1. And one of the properties of the diagonals of a rhombus from your chapter 6 work is the diagonals of a parallelogram are perpendicular to each other, and for all parallelograms, they bisect each other. So, if this is going to be, if this is going to be diagonal number 1, then this piece is exactly half of diagonal number 1. And if the red diagonal is diagonal number 2, then this piece is exactly half of diagonal number 2. These four right triangles are all congruent because of SSS. They have the same 3 side lengths, SSS, all 4 of them. So what we can do to get the area of the rhombus is first get the area of this triangle and just multiply by 4. So here we go. The area of the rhombus must be 4 times the area of that red triangle. That red triangle is congruent to each of the other 3. So let's see what that comes out to be. 4 times area of a triangle from earlier in this video is 1/2 times its base times its height. So I know that's kind of messy there, but it's going to clean up nicely. 4 triangles, and each one of them has an area of 1/2 of its base times its height. Its base is half of a diagonal, and its height is half of the other diagonal. If we multiply this together, 4 times half times half times half. 4 times half is 2. 2 times half is 1. 1 times half is half. All those numbers multiply to just make half. And then we're left with D1 times D2. So I did that quickly. You can watch it again if you need to, but the end result, the formula is area of a rhombus is you multiply the diagonals together, and then you multiply that product times 1/2. So we'll do some examples in the next video, so stay tuned.